Hello, thank you for checking out Mr. Ware's videos, and today we're looking at solving some equations here. And we got some one step, we got some two step, got some literal equations, and that's what we're going to do today. So I'm going to start off with some notes. And the first note here is that to identify the inverse operation, you use this inverse operation to isolate the variable to one side of the equation. Okay? So think of solving equations like lifting weights. You want to keep everything balanced. So if you add or subtract the number from one side of the equation, you must add or subtract the same number from the other side of the equation. Okay, so let's take a look at a few examples here. And I like to think about it as doing the opposite. So it says here, I got P plus 30 equals 22. We're going to do the opposite of adding 30, which would be to subtract 30. So I subtract 30 on both sides. And then this will cancel out. 30 minus 30 is 0. So I'm bringing down this P, and P is equal to 22 minus 30, which is negative 8. Alright, now let's take a look at number 2. Alright, number 2, we got D minus 5 equal 19. We're going to do the opposite, and we're going to add 5 on both sides. Okay, doing the opposite. So we have negative 5 plus 5, that's going to cancel out. Let's get you 0. So D is equal to 19 plus 5, which is 24. Okay, that's the adding and subtraction one there. Let's see if we can look at a different one. All right, now zoom this back out here. And when you are solving the equation, your goal is to use the inverse operation to isolate the variable on one side of the equation. If you multiply and divide by one number from one side of the equation, you must multiply and divide by the same number on the other side to keep it equal, right? Same thing with the lifting the weights. So we're going to, if we multiply on one side or divide, we do it on the other side. And you always do the opposite. So I'm going to zoom in here on number 1. We've got 3 times P. Okay, so we'll do the opposite of multiplication, which is division, and divide by 3. And then P is equal to 18 divided by 3, which is 6. Alright, now let's look at this one. We've got B being divided by 6. 5 is equal to B divided by 6. We do the opposite and multiply by 6. So to make this a fraction, I'm going to put it over 1. And like I said, do the same thing on both sides. Multiply by 6. Okay? Okay, these two 6's is going to cancel out, leaving B over 1, which is the same as B. And then 6 times 5 is going to be 30. So B is equal to 30. Alright, those are one-step equations. Alright, let's see what we got next. Two-step equations. Alright, an equation is a statement that one expression is equal to the other. It contains an equal sign. Pretty simple, straightforward, right? Here's an example of an equation. 3x minus 1 is equal to 14. Okay, we've got the variable term right here. And you got the constant term right here. Notice the difference. The variable term is an equation that includes the variable as a factor. Okay. See how I got 3 times that? X times 3. That's the variable term. The constant term is the equation that does not include a variable. But basically, this is your constant term right here, that negative 1. So the goal when solving an equation to isolate the variable by using inverse operations, doing the opposite, to reverse the order of operation. This allows you to transform the equation into x equal some type of value, right? So we eliminate the constant by adding or subtracting. We eliminate the coefficient by dividing or multiplying. So, so let's take a look at this first one. Two-step equation. Okay, we got x divided by 3 minus 5. We're going to deal with the constant. The opposite of minus 5 is plus 5. And you do plus 5 on both sides. Alright, we got x divided by 3. So we got x over 3. Alright, that's going to cancel out. And then we got 1 plus 5, which is 6. Alright, next, we're going to do the opposite of dividing by 3 and multiplying by 3. Okay, I'm going to multiply by 3 on both sides. Okay, the 3's are going to cancel out. Make sure that cancels out, right? X over 1 is x, and so x is equal to 6 times 3, which is 18. All right, let's look at number 2. We're going to work with the constant first. Instead of adding, subtract 5. If I could draw 5 on both sides. The 5's cancel out. I have 3x is equal to 35 minus 5, which is 30. And then I'm going to divide by 3. Yep. Alright, had a little glitch here. Let's see if I can fix that. Alright, I'm going to divide by 3. And x is equal to 30 divided by 3, which is 10. Not negative 10, just 10. Alright. So here, we've got 20 is equal to 16 minus b over 5. On these right here, we was working to the right side because the variable's on the left. Here, since the variable's on the right, we're going to work to the left. Notice the difference. It looks like 3 terms here, right? And it's 3 terms, but notice that on the first two, the 2 terms are on the left, and 1 is on the right. 2 on the left, 1 on the right. This one, you have 2 on the right and 1 on the left. So we're going to work away from the variable. Always work away from the variable. So I'm going to zoom in here. We're going to subtract 16 on both sides. 20 minus 16 is 4. Alright. We're going to have 4 is equal to negative b over 5. Keep that minus in there. Don't let that drop off. Okay, and now I'm going to multiply. Since I want the b to be by itself, I'm going to multiply by a negative 5 over 1. That way, negative times a negative will make it positive. Okay, so I'm going to multiply by negative 5 over here. So that's going to leave me with negative 20 is equal to b. Alright, let's look at number 4. Again, with this one we got the 2 variable or the 2 terms to the left, so we're going to work our way to the right now. So instead of minus 7, we're going to add 7. Work with the constant term first. Okay, I'm going to bring down this 4x. It's equal to 5 plus 7, which is 12. And now I'm going to divide by 4. And x is equal to 12 divided by 4, which is 3. Alright, and those are all of the 2-step equations. Alright, let's take a look at one more thing. Alright, so we got multi-step equations, and we got multi-step equations with variables on both sides. But what I want to work with right now is literal equations. Okay, so literal equations. A literal equation is often known as a formula, as it contains more than one variable. It contains more than one type of variable, I should say. Okay, literal equations. So formulas like base times height is equal to the area. See how you got more than one variable? So more than one variable is a literal equation. Or let's say y is equal to mx plus b. literal equation. And even if you plug in some numbers here, like y is equal to 2x plus 5, that's still a literal equation because it has two or more variables. All right? And that's why they call it the slope-intercept formula. So formulas are literal equations. Let's take a look and see what else we got here. All right, now the same thing you do with regular equations is the same thing you do with literal equations. You do the opposite, the inverse operation. But when you do it, sometimes you can't solve it because they letters, they variables. You can't always solve a variable like that. So let's take a look at some examples. All right. So on the left side, or on number one, you got a regular equation. It's not a literal equation, okay? But what you want to do here is go ahead and solve for W like normal. And then you can see the problem next to it is going to be a lot the same. So I want to solve for W, so I'm going to divide the 4 on both sides. 20 divided by 4 is going to be 5. And then the 4's cancel out. 4 divided by 4 is 1. Bringing down the W, and W is equal to 5. Makes sense. 5 times 4 is 20. Regular standard equation. But this one is a literal equation. I'm going to solve for W. So we're going to do the same thing. We're going to divide by L. Instead of 4, it's L, because I want to get the W by itself. So now I'm dividing by L. And now that's going to be A divided by L. See, over here, I can do 20 divided by 4 and get 5. But I can't do A divided by L, so I'm just going to say A divided by L. And it's equal to the L's canceling out, leaving W. All right, let's take a look at a few more. Here, we are isolating the C. We want to get that by itself. And with literal equations, they have to tell you what they're solving for. If they don't tell you what they're solving for, you won't know what to do because it's more than one variable. All right, so now I'm going to subtract 3a on both sides. Okay. And when I do that, this will cancel out, leaving just c. So c is equal to 12 minus 3a. And when you solve for literal equations, you don't get just a constant number. You get an actual expression. It's going to be equal to an expression. So here, W is equal to this expression. C is equal to this expression. All right, let's take a look at one more here. We've got AB, and I'm going to zoom in a little bit, and plus C is equal to D. We want to solve for C, so I'm going to isolate this C by subtracting the whole AB on both sides. This will cancel out, leaving C, and C is equal to D minus A times B. Alright, and that's a quick little 15 minutes or so, actually 14, on equations. We did one step, add, subtract, one step, multiply and divide, two step, deal with the constant, then deal with the coefficient, and then some literal equations, more than one variable. And all of this is done by inverse operations, with some of the properties being addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. So that's it for now. Stay tuned for part 2 of this, where I go over multi-step equations, some with the variable on one side and some with the variable on both sides. But for now, thank you for checking out Mr. Ware's videos. Have a nice day.